In the last session, we have learned Fisher's index number with FRT. In this session, we shall take a problem number 32, showing whether Fisher's index number satisfies TRT and FRT. Let's see. The problem is given the items 2016, 2018. So 2016 is our base year, 2018 the early year will be the current year. They have given the price and quantity. So first copy the table with 9 columns we want. Item P0, Q0, P1, Q1 as it is given. Now, we'll complete the further 4 columns. What columns you require for Fisher's? We want P0, Q0, then P1, Q0. That is each price multiplied with each quantity, the 4 regular columns that we prepare. Let's see the multiplication for that. P0, Q0. When you take a P0, Q0, it's 8 into 15 is 120. 7 into 12 is 84. 10 into 10 is 100. 12 into 14 is 168. And quickly get the total of this, which comes to 472. Now, P1 Q0 here. P1 Q0, 15 into 9, 135. 8 into 12, that's going to be 96. Then it's going to be 10 into 10, 100. And then 15 into 14, what we get is 210. The total of this comes to 541. Next, P0 Q1. P0 8, Q1 is 15. So the answer what we get is 120. P0 7, Q1 13. 13 sevens are 91. P0 10, then Q1 10, it's 100. Then 12 into 16. What we get is 192 and the total 503. Then the last one, P1 Q1, 9 into 15, 135. Then it's 8 into 13, 104. 10 into 10 is 100. Then it is 15 into 16, 240. And then we get the total, that is 579. Now, we should test whether Fisher's index number first satisfies TRT, then we'll move on with FRT. Let's see. Fisher's index number with base year 0 and current year 1, the regular formula we should put up for Fisher's. P01 is equal to root of last year's formula, summation P1 upon P0, we multiply by the quantity of the base year, into summation P1 divided by summation P0, multiply with the quantity of the current year, we get pastures. Let us substitute the values. P1 Q0, P1 Q0, 541. This divided by P0 Q0, 472. Into P1 Q1, 579. This divided by P0 Q1 is 503. Keep it as it is. Shouldn't solve it. Because we have to test whether the answer is equal to 1 or no in TRT. So don't solve it here by using the calculators. Keep it as it is. Later on when we cross multiply, it becomes easy if you are not solved it. Let's see further. Fisher's index number now with time reversed. Time reversed means what? Base year which is 0 will be taken as 1. And current year which is 1 will be taken as 0. We should rewrite the formulas, changing the time, not the factors, P and Q as they are. So here, what the formula will be? That's going to be P10 is equal to root of, first let me write the factors. Now we'll change the time. P1 Q0. P1 Q0 becomes what here? P0 Q1. P0 Q0 becomes P1 Q1 into, again the factors as they are. P1 Q1 will be taken as P0 Q0. P0 Q1 will be taken as P1 Q0. Substitute the values in this. Root of P0 Q1 503 divided by P1 Q1 579 into P0 Q0 472 divided by 541. Again, don't solve it. Let that be as it is. Now we'll see. To satisfy TRT, what it requires, when you multiply P01 with P10, the answer should be always equal to 1, as learnt in the earlier sessions. Now let's see. P01 into P10 is equal to 1. So, P01 we are going to multiply by P10. First answer 541, this divide by 472, this into 579 divide by 503. This P01 will multiply by P10, that is root of 503 divided by 579. This into 472 upon 541. Let's see how to solve it. Check out first. Can we cancel anything? 541 can be cancelled if it is on the denominator. Yes. 472 is on denominator, so cancel it with the numerator. Yes. 579 can be cancelled. 503 can be cancelled. So when you multiply P01 into P10, the answer what we get is equal to 1. That means what? Fisher's index number satisfies TRT. That is what already we have learned in the earlier session. Specify. Thus, Fisher's index number satisfies TRT. Now we'll check out Fisher's index number with FRT. And to do that, first, Price index number as it is. Reverse the factors, factor reversal test. It becomes quantity index number. When you multiply, the answer should be value index number. Value index number means what? P1 Q1 divided by P0 Q0. Let's say Fisher's price index number. I'll be writing up the same formula now. Same formula, and then we'll substitute the same values. So the same price index number as written here is been shown there. No change. Now, Fisher's quantity index number with factor reverse. Factor reverse means what? We reverse the factors. P, the price, we take as quantity. And Q, the quantity, we take it as price. And when you reverse the factors without changing the time, price index number becomes your quantity index number. Let's see. Q01 is equal to root of summation P1 Q0. Where there is P, we take it as Q. Don't change the time. It's not time reversal. Time will be same. Q0 becomes P0. This divide by summation Q0 P0 into summation Q1 P1. This divide by summation P0 becomes Q0. Q1 becomes P1. Now we'll substitute the values. Root of Q1 P0. See, where is Q1 P0? Q1 P0. Q1 P0. Q1 P0 or P0 Q1. 2 into 3 or 3 into 2. Answer is same. So Q1 P0. What is the summation? 503. This divide by Q0 P0. 472. Into its P1 Q1, that is Q1 P1, 579. This divide by Q0 P1, 541. 541. We'll multiply that, and after multiplying, this is the answer, what it should remain. Now, this is the answer, means what should remain, see? What is P1 Q1? 579. And what is P0 Q0? 472. This has to be the answer. This has to be the answer, what we solve here now. Let's see. P naught 1 into Q naught 1. P naught 1, the first one. 541 divided by 472 into 579 divided by 503. This will multiply with Q naught 1. $503 divided by 472, 579 divided by 541. Let's see whether we can cancel anything. Can we cancel 541? We can cancel this numerator if we have the same number on the denominator, yes. Can we cancel 472? We can cancel this denominator if we have the same number on the numerator. Check out 472. Do we have on the numerator? No, we can't cancel it. 579, do we have on the denominator? No, we can't cancel it. So what can be cancelled is 503. P naught 1 into Q naught 1 is nothing but 579 divided by 472. This into 579 divided by 472. What we want is P naught 1, when you multiply by Q naught 1, the answer should be equal to value index number, which we have taken as 579 upon 472. Now, is it equal to this or no is what we have to check out. See, the numbers in the root are same. So, how we solve it? We find the root of that and then we multiply. Say, for example, if it is like this, I say the answer is 25 upon 16 before we solve. Why? Root of 25, 5. Root of 16, 4. Root of 25, 5. Root of 16, 4. 5 into 5, 25. 4 into 4 is 16. So there is no meaning in first finding the root and then multiplying the same numbers to get the same answer. So once you see this, in the two root, the values are same. We say that the answer is equal to the number what is there. So the value has to be same. So P naught 1 when multiplied by Q naught 1, we get the answer. So write down that Fisher's index number satisfies FRT. Let's see. Thus, Fisher's index number satisfies FRT. This is the only index number which satisfies both the tests. And that is the reason why we say that Fisher's index number is ideal index number. So in this session, we have completed problem number 32 on TRT and FRT with Fisher's. In the next session, we'll again take up a problem on this time reversal test with Fisher's index number. Thank you.